So, my name is Angelica Vidas, and this is my AAI Who Can project, which is the NASA Exoplanet Detection with AI. So, in simple terms, when a planet passes in front of a star, the star's brightness dips a little. That dip is called a transit. Those signals are hard for non experts to read, and a lot of dips aren't planets at all. They can be considered false positives. So, the purpose of my app is to help people explore the idea by looking at a light curve, getting classification, and read or hear an explanation in plain language. So, what's the problem? So, there's already a NASA style light curve data that's publicly available, but interpreting it usually takes training, meaning it takes domain knowledge. A number on a screen isn't enough, and people need to actually see the dip to understand what it means. So, the problem, so what does it mean? The solution that I'm offering is by creating a web app where you can select sample light curves, where you can select sample light curves. Um, the app will help you visualize the flux over time, classifies whether it looks like a planet candidate or a false positive, and you'd be able to read an educational explanation as to why it would either be considered a planet or a false positive. So you can see this is the web app. Here's the live app actually. And on the home page, you can see if you scroll down, the project overview, um, which is to classify, visualize, and explain. And like a quick little thing where it says watch a star's brightness dip, classify whether it looks like a planet transit, and get plain language explanation built for learners, not telescope operators. And if we scroll just slightly more down, you would be able to see side-by-side comparison of a planet-like signal versus an eclipsing binary false positive. We're going to start with a clear transit, and we're, in our case, load the starter sample, which is the Kepler light clear transit. So I am going to run classification. Um, so but before that, I wanted to show that this part right here is showing the brightness over time, and we can see the repeating dip. Now, when in classification, we will be provided with the um, with the verdict that the model provides, whether if it's planet candidate or false positive. In our case, it was the planet candidate, with the confidence, the key features like transit depth and SNI proxy, and a plain language explanation. That's also a what this means call out. So non-experts understand that the purpose of this is that this is educational and non-official NASA planet confirmation. I'm gonna quickly start one more sample, the eclipsing binary style false positive. So we're expected a false positive. So this is how it looks like. The brightness chart once again. And if I choose the run the classification, um, we can see the once again the planet candidate and what this means and the explanation. So the purpose of showing this other example is so you can see how lookalike signal can be classified differently. And in the history section, the recent runs are saved, so I can revisit them at any moment. So as you can see, there's a timestamp and a date provided. For the AI, let's kind of look at the Kepler, the Kepler like clear transit. So for the AI used, there are two layers: a classifier that scores planet candidate versus false positive using light curve features, and an explanation layer that turns those features into everyday language. The stack is the next.js for the web app with the optional fast API ML service. So basically, this path works even without extra services because the web API has the built-in fallback. Um, and to wrap this up, um, this project turns open scientific light curve concepts into an interactive learning tool by classifying, visualizing, and explaining what these dips are occurring, what these dips are doing. So the live app is, as you can see, this the NASA Exoplanet Detection .versal.app. And all the docs and artifacts are in the GitHub Classroom repository, as seen here. That's the link. Everything is here. And so thank you for watching, and I'll be happy to take any questions regarding this.